Ladies and gentlemen, the final of our first presenters is Kay Higginbotham from the School of Geology, University of Canterbury. The title of her presentation, Quake-Cano, Exploring How Earthquakes Trigger Volcanic Eruptions. Welcome, Kay.
All right, show of hands, who here saw Sharknado? Oh, excellent. Yeah, complete B-movie badness. The movie is literally about sharks in a tornado. Now, this movie didn't contribute a whole lot to society, but one thing it did teach us is that one hazard is bad, then two hazards is Sharknado bad. And using this logic, we already know earthquakes, not awesome, but earthquakes triggering volcanic eruptions, or Quake-Cano, is probably going to be worse. And here in New Zealand, we know earthquakes are at best a hassle and at worst a complete disaster. And there's a lot of other hazards associated with them. With tsunami, rockfall, liquefaction, or down in Christchurch, insurance companies. But one thing we don't often consider is volcanic eruption. However, past research has shown that earthquakes can and do trigger volcanic activity. But what we don't yet understand is the physical mechanism that causes this. Now, to understand this, we need to know a little bit about volcanoes and bubbles. Volcanoes are like bottles of beer. There's gas dissolved inside the liquid until pressure is released, kind of like cracking your beer open. And that gas can either come out quietly or slightly more catastrophically, depending on how your bubbles behave. So what I've done is I've run a series of experiments to look at how bubbles actually behave during shaking. Unfortunately, magma is slightly tricky to handle and, according to my department, a health hazard. So instead, I've used transparent silly putty, which I now have 100 kilograms of, and I've placed this into a tank that's attached to a shaking table. The tank is sealed, I inject bubbles in, and then I subject them to different levels of shaking. The whole process is filmed so that I can track the changes that occur before, during, and after. Now, what I'm really interested in seeing is whether bubbles will rise faster during shaking, which may lead to a process called advective overpressure. As bubbles rise in a sealed system, pressure increases. If you increase pressure in your volcano, then we tend to get out the top. So, if shaking does cause bubbles to rise faster, then we can increase the pressure in our volcano, leading to advanced eruptions that we weren't expecting. Analysis is ongoing, but my results are showing that bubbles do rise faster during shaking. And this is occurring in all of the fluids that I've tested and for all of the bubble sizes. And that's really interesting to me because it means that a wide variety of volcanoes may be susceptible, from your little Hawaiian islands up to the big mech daddies like Taupo here on the North Island. However, volcanoes are very complex systems and there's still a lot of variables to look at. But by better understanding how bubbles behave during shaking, we can better understand the Quake-Cano connection. Thank you.
Thank you, Kay. Judges.
Yeah, thank you, Kay, for a reminder that we sit on a shaky plate. I think any work that's being done in this area where the community has to face potential disasters and the unknown as to whether disasters happen or not, any work that can be done to increase the predictability of the calamities that might arise from the combination of the two, at least, is really useful and very valuable. Thank you.
Yes, thanks, Kay, and congratulations on your use of humour for what is a very relevant issue for our country. I certainly enjoyed your description of your experiments, but also the explanation as to why you have gone about doing exactly that. Thanks for also sharing your tentative sort of findings, and I sense that this is just the start of something that's more to come. Thank you.
Congratulations, Kay Higginbotham.